Good morning, grade 9. Sorry I couldn't make it to our lesson today. I had car problems. Let's just go through algebraic expressions. We did this last year. I will just be revising some of the important concepts, okay? We'll start first by definitions, and you should remember this from last year. A term is an expression that stands alone. Hence, it is a positive or negative single number variable or numbers of variables multiplied together or divided, except when it is enclosed in brackets. And I gave you examples of a term there. It's 2, -3. 6x is also a term where you have an integer multiplied by the variable x. 7x squared is also a term where you have an integer 7 multiplied by a variable x, and that variable x has an exponent of 2. They can either be divided or multiplied. And then we've got 2x divided by 3x, which is 3x squared, which is 2 divided by 3x. That is also a term. It's linked by division. The last one will be linked by multiplication, where you have 2x times 5, which is simply 10x. That is a term, okay? Except when it's enclosed by brackets. Enclosed in brackets simply means that 2 plus 3 will be one term because it's enclosed inside the brackets. And we've got 2x plus 7, it's enclosed by brackets as well. So that is one term, even though there are two terms inside the bracket, but because of the bracket, that bracket enclosed them and it made them one term. And we have 5x plus 1, that is also one term. 5x plus 1 all squared, that is also one term. A term can only be separated by plus or minus, unless, as I've said, they've been enclosed in brackets. A polynomial is an expression consisting of coefficients of variables, and the exponents of the variables are positive integers. So they mustn't be fractions, they must be positive integers. Polynomials are simply algebraic expressions with one or more terms. Now, examples of polynomials will be x plus 2. This is a polynomial with the highest degree of 1. That highest degree is a positive exponent of the variable. You'll realize that we only have x there. Since there's no exponent written for x, you by now, since we have done exponent, you should know that the exponent of that x is 1, okay? The exponent of that x will be 1. Now we've got, well, the first one, we normally call it a binomial because it's an expression with, it's a polynomial with two terms. So it's bi means 2, okay? Note that there are two terms that are separated by plus or minus, and they're not like terms, so we can add them. The second one, the second example is x squared plus 2x plus 1. This is a polynomial with the highest degree of 2. That is because the variable x, the highest degree of the variable x is 2, because the x in the middle only has the exponent of 1, so the highest degree will be 2. The last one, this is a polynomial with the highest degree of 3. That is because the highest exponent of the given variable x is 3. Expressions of algebraic expressions, well, here I was supposed to say algebraic expressions that are not polynomials will have 4 divided by x squared. Please note that the exponent is in the variable is in the denominator, as I've explained. The variable will be in the denominator. If you were to simplify this, it'll be 4 x to the exponent of -2. And remember, we said the polynomial cannot have a negative exponent. Instead, it must have a positive integer. Okay, it must have a positive integer. All right, it must be a positive integer. It cannot be a negative integer. All right, and here we have, this is not a polynomial because here, this x here is not an integer. It is not an integer. It is not an integer. That half, it's simply a rational number. It is not a, it is positive, but it is not an integer. Therefore, that expression doesn't qualify to be a polynomial. And the third one, we've got cube root of x squared. When you simplify this, you will write it as x to the exponent of 2 divided by 3. Again here, 2 divided by 3 is not an integer. It is not an integer. It is a rational number. Therefore, that is not a polynomial. And then we've got t to the exponent of -5. -5 is an integer, but it is not a positive integer. It is not a positive integer. As a result, that t to the exponent of -5 is not a polynomial. Remember, for an expression to be a polynomial, the exponent of the given variables must be a positive integer. And you need to remember terms are only separated by plus or minus. If they're enclosed in bracket, we don't consider them as separate terms, but we consider them as one term. Now let us look at this expression here, where we have 3x cubed plus 2x squared minus 3x plus 9. How many terms are in the above expression? Let's start counting them. We've got 1, 2, 3, 4 terms. So this expression has 4 terms. Remember, terms are always separated by addition and subtraction. There are 4 terms. Terms are always separated by addition and subtraction. Now state the variable. The variable there is x, right? The variable is x. What is the coefficient of x? You will need to look at all the variables we have. The first term, the exponent there of x is 3. The second term, the exponent of x there is 2. The third term, the exponent of x is 1. And here they ask you for the variable, for the coefficient of x that has an exponent of 1, because we don't write the exponent of 1. Now, coefficient, it is an integer that is multiplied by the variable, or simply it can be a variable as well. As long as it's not x, it becomes the coefficient of x. So it is an integer or any variable that is not x that is multiplied by x. In this case, we have an integer which is -3. That -3, we will call it the coefficient of x. Now, just to clarify what I've just said, let's say you have 3yx, and I ask you, what is the coefficient of x? The coefficient of x in this example will be, this 3y, okay? It's simply an integer or variable that is multiplied by x, okay? That is linked to x in this scenario. Note that we are expressing this in terms of x. Since we're expressing it in terms of x, the coefficient will be any variable or number or integer that is linked to x, that is multiplied by x. Now, what is a constant? A constant is simply any integer, okay? For now, it's any integer, but later on, you will actually learn about dependent and independent variable. So if x is an independent variable, I don't want to actually even confuse you with that. You will learn about that later on. For now, just know that it's an integer that doesn't have the variable x. Now, 9 in this case will be our constant. 9 will be our constant. Do this one quickly. Answer the first question. What is the highest degree of x? It is 3. Note that we've got variable x, we've got variable x, we've got variable x. You need to look at the variable that has the highest exponent, which is in the first term. And in the first term, the variable x has the highest degree of 3, okay? Now that 3 will be the highest degree, will be the degree. And that's why we say 3 is the highest degree. What is the coefficient of x squared? The coefficient of x squared will be 2. If 10 is added to the expression, how many terms will there be in the expression? So you're going to take the whole expression, which is 3x cubed plus 2x squared minus 3x plus 9, and add 10 to that. Note that 9 and 10 are like terms. 9 plus 10 will just give you 19. Now let's count how many terms we've got. It's 1, 2, 3, and 4. So in this case, we still have 4 terms. How many terms are in this fraction? State the variable and what is the coefficient of x. We are going to have how many terms? Remember, terms linked by division or brackets are considered to be one term. So we're going to have 1, 2, and 3 terms. What is the variable? The variable is x. Now, what is the coefficient of x? I want to write this down. The coefficient of x here, you will have to distribute the denominator. When you distribute the denominator, you will have 2 you will have 2x divided by 5 plus, so you are just distributing the denominator to each of the terms in the numerator. And then you'll have 2 divided by 5. Now, by so doing, please note that you have isolated the coefficient of x. In this case, the coefficient of x will be 2 over 5. What is the constant? The constant is just -2. Now, please do this as classwork. I will give you 5 minutes. Now let's check how many terms we've got. We've got 1, 2, 3, 4 terms. And the highest degree here is simply 3, as you have realized. So we've got 4 terms. The variable is x, and the coefficient of x cubed will be 2 over 5. The constant will just be negative 25. Okay, we have done this already, the degrees of polynomials. Arrange the following polynomials in descending powers of x. Okay, please note that here when they ask you to arrange this in descending powers of x, you need to look at the variable x that has the highest degree and the second highest degree, so on and so forth. So in this case, you look at the exponent of each variable of x and start with the term that has the variable with the highest exponent. Remember, the sign of the term belongs to the coefficient behind it. So if I have negative, let's say 5x squared, negative 5 belongs to, negative belongs to 5, which is the coefficient behind negative, which is 5. Just remember that. So meaning that if I've got 2 minus 3x, this negative cannot belong to 2. It belongs to 3. So it's negative 3. Just remember that. Okay, so when you rearrange this, please note that you keep the core. This, I was worried about this one here. Please note that for this term has a sign that is negative. So that negative will always be in front of 2x cubed. So that is why when I arrange this, I arrange them from the highest degree, which is 4, which is the exponent, the highest exponent of the variable x, and the second highest exponent of variable x is 3, the third highest exponent of variable x is 2, and the last or least highest exponent of x is 0, which is just 1, because we never write 1. That's why you've got only that integer, which is just 2. Okay, now let's arrange the following polynomials in ascending powers of y. Okay, not x, but of y. Try it. Now here we look at the exponent of each variable y and start with the term that has the highest variable, okay, that has a variable with the highest exponent of y. So we just look at y's and only look at the exponents of y. Here it's 1, there it's 3, and there it's 5. So we arrange this in ascending order. It means that it's from the lowest exponent to the highest exponent. So when we arrange this, we're gonna, interestingly here, already it has been arranged in ascending order. So you're gonna write it as it is, which is 3x squared plus 2y, and then you plus, actually it's minus, it is minus 2x to the exponent of 3, and then we're going to have y to the exponent of 3. And then we're going to have plus 6x to the exponent of 4, y to the exponent of 5. Remember, we're just looking at the exponents of y, which is 5. The second highest will be 3. So ascending means from the lowest to the highest, the lowest to the highest. So the lowest exponent of y here will be y to the exponent of 0. But because y to the exponent of 0 is 1, we do not write it. So it will be 3x squared y to the exponent of 0 plus 2y to the exponent of 1 minus 2x cubed y to the exponent of 3. Note that if I was to ask you, what is the coefficient of y to the exponent of 3? Your answer will be that the coefficient of y to the exponent of 3 is negative 2x. Okay, is negative 2x because this is expressed in terms of y. Okay. All right. Let's continue. Ooh, it looks like I am done. It is your turn. Please do exercise 1 on page 53 of book A. Calm. Keep it calm and rock this classwork, okay? See you guys tomorrow. So tomorrow I'll just be checking if you have done this classwork. Okay, make sure it's in the ABC. I think it's book A in the ABC books. Exercise 1 on page 53. The first one, if I'm not mistaken, you tick on the table whether the given expression is a polynomial or not, and then you state the degree, and then you calculate the number of terms. Okay, enjoy the rest of your morning. See you guys tomorrow. Please make sure that everything that is in this video is in your notes tomorrow, okay? Otherwise, you're gonna be in trouble. What's all?